Welcome back to physics class. Today we are taking new chapter, that is human eye and colorful world. In that part, in the chapter, that consists of refraction through prism. We already learned refraction through glass slab. It was very easy for us. We come to some two conclusions, that is incident ray and emergent ray are parallel to each other. Angle of incidence is equal to angle of emergence. That's all we learned that in that case. But today something different is there for prism. You know what is prism? You already learned in mathematics class. What is a prism? Probably you learned about wooden prism. But here it is glass prism, because light will pass through only glass. So we can consider a glass prism here. And how many lateral surfaces a glass prism have? It consists of 3 rectangular lateral surfaces and 2 triangular bases. So we can see what will happen if a monochromatic light is passing through a prism, glass prism. That is, if a monochromatic means one kind of color. Suppose we are taking yellow, what will happen to yellow color? Not a white light. We cannot use here white light. White light will undergo dispersion. Instead of that, we are taking one kind of color only. Okay. We can draw how light is passing through a prism. Okay. Consider a normal line. First we can draw a normal line from in the surface AB. Okay. Here I drawn a normal line and I named as N. Then we can draw the incident ray. Okay. Yes, I drawn an incident ray and I named as P, Q, and angle between the normal and the incident ray is known as angle I. Angle between the normal and the incident ray is known as angle I. That is, angle I is known as angle of incidence. The next one, what will happen here as it enters through a glass? It will undergo refraction and it will bend towards normal. That also we can draw. We can put an arrow mark and we can name it as QR. And the angle between the refracted ray and the normal is known as refraction, angle of refraction. And what will happen here? Yes, there will be a refraction and emergent ray will be coming out. And we have to draw a normal here also. And I named as N dash normal. Second one N dash I named as. And here we need the emergent ray coming from R. It will undergo refraction here and it will bend away from normal. Okay. Yes. And the angle between the normal, second normal and the emergent ray is known as angle of emergence, and this is known as emergent ray. Emergent ray. So we know that angle R is the angle of refraction and angle E is the angle of emergence. And can you find out any difference or similarities between angle of emergence and angle of incidence, or incident ray or emergent ray? We can consider anything. As in the case of the glass slab, we can say that incident ray is parallel to emergent ray. But here we cannot say that incident ray is not parallel to emergent ray. We can see that. Sure, we are sure about that. But we can say one thing. If there is no prism, what will happen to the incident ray? The incident ray will go straight like this way. If there is no prism. And what will happen to emergent ray? As it was, we can extend backwards. So the angle between the emergent ray and the incident ray is known as a new angle deviation, angle of deviation. How much refraction is undergone by the use of this prism? This measure will we get from this angle of deviation. It is very important here. So about angle B is known as angle of deviation. And here one more angle is there in between here, that is angle of prism. Angle A is known as angle of prism. So this much are about a refraction through prism. If one kind of light is passing through, monochromatic light is passing through a prism, what will happen to this? Yes, definitely it will undergo a refraction. Two refraction will be there. The first refraction at the side AB and the second refraction will be at the side AC. Two refractions. So we will get two refraction angles, that is R2 and R1. So two refractor angle is there. Angle of refractions, that is R1 to R1 and R2. Angle of incidence is there. Angle of emergence is there. And we can say that angle of incidence is not equal to angle of emergence. And incident ray is not parallel to emergent ray. But here we can say that angle of deviation, that is angle between the incident ray and the emergent, is known as angle of deviation. That's all about the prism. We had to learn how to draw this diagram. Okay. The next part after refraction through glass prism is the dispersion through glass prism. You already learned what is dispersion in class 7. It is a phenomenon of white light splitting into 7 colors. White light consists of 7 colors, that is VIBGYOR. So we can see how this VIBGYOR can be obtained in a lab. Natural dispersions are there. In the case of the rainbow, we can see it is a natural dispersion. Sunlight consists of white light. White light when passes through prism, it undergoes splitting and it turns into 7 colors. Here we can see that when a white light falls on a prism, it splits into 7 colors. The top is red and the last is violet. Here we can say that the red deviates least, the red bends the least, but the violet bends more. So we can obtain a VIBGYOR from a glass prism. In the lab itself we can see that VIBGYOR and we can understand how it is, what is happening here. What is the reason behind this different color formation? Can you say that? Can you think about it? What is the reason behind this? Yes, the reason is that white color consists of these 7 colors. Each color when enters this prism split, but each color have different speed and they split at different angles. One split in one angle, other split in another angle. So they will split and we can separate these colors. But I am not saying that we can separate red from the VIBGYOR, violet from the VIBGYOR. Not it's not. We can see the separate colors. And this is about the dispersion of light through a prism. Once more I will say, dispersion is that splitting up of white light into 7 colors, that is violet, indigo, blue, green, yellow, orange, red. We already studied about the dispersion through a prism. What will happen? If white light falls on a prism, it split into 7 colors. The topmost color is the red and the last color is the violet. Why red become topmost? Yes, it bent very less. It does not undergo bending so much. It bent very less. But in the case of the violet color, it deviates more. So what is the reason behind these all things? We can see that red versus violet. We can differentiate each color. The topmost color red, which is used as a danger signal. Always when there is red signal means it's danger. Some kinds of danger. We are far distance itself. We can see the red color far away from itself. That is, it can travel so much of distance. Therefore, it consists of high wavelength. But in the case of the violet, we can see red have large wavelength, but in the case of the violet, less wavelength. We cannot see the violet, blue, indigo colors from far distances. The second one is the large speed. Red can travel in a high speed but violet, indigo, blue cannot travel in a high speed. And the next one is the bending. Yes, we already said about the bending of light. Bending of light is very least in the case of the red light. And in the case of the violet light, it bends more. And the last one, less refractive index. We already studied what is refractive index. If the medium is denser, the refractive index will be very larger. If the medium is rarer, then the refractive index is very less. So we can see in the case of the red color also, the refractive index is very less because this light have much speed and also it is much denser, rarer comparing to the violet. And violet have high refractive index, so it undergoes more bending towards normal. Now the next one is less scattering. Yes, this does not undergo so much of scattering, so it can travel so much larger distances. But in the case of the violet, it cannot travel so much of distances. It will scattered up. So this can be the reason behind why sky appears blue color. And during the sunset and sunrise, why sky appears red color. These answers we'll get from the next classes. Okay. Thank you all of you.